as we have talked in our previous lecture, that this course is developed to concept the understanding of functions of several variables, in which we are discussing about limit, continuity, differentiability, problems of maxima and minima, and we shall see how these concepts are resemble and how they are different than the single variable. Since most of the theorem that can also prove for functions of two variable and can extend also for functions of three variables or more, we ourself is limited. We are doing everything for only for 2 and 3 variables. In this lecture we are discussing about the what is the functions of several variables. For example, I am starting with the rectangle. If I have a rectangle, it has a height is a if I define, and the length is b, then we know that the area of this rectangle will be AB. Now if this area is increased, that means its A is increased or B is increased, or area is decreased, then A or B will be decreased. Then we can say that this area is nothing but the functions of this two variable AB. Okay, so I can define a function f which is a function of AB is equal to A into B. So this function f is a functions of two variable A and B, which is the length and breadth of this rectangle, and it gives the output as the area of the rectangle. So with that concept we can define functions of several variables. Suppose I have a set Rn. Everybody probably know what is Rn is. The Rn is the n tuples of real numbers, that is x1, x2 up to xn, where each xi is belongs to R. For example, if you have R2, then this is the order pair xy where x and y belongs to R, and you know that in the geometrically you can represent this two-dimensional space as in xy coordinates. So if you have any given point xy here, then you know that this distance is y, which is a perpendicular on x-axis, and this distance from origin to this point, which is x. So this is the things you know. And also you have R3, which is three triplets, that is x, y, z, where x, y and z belongs to R. So and geometrically this will represented as, if you consider this is your z axis, if this is your x axis, and this will be your y axis, and if you have a point x, y, z in the three dimension or in the space, then this distance, if you draw a perpendicular on x z plane, this distance is y. Whatever the perpendicular distance from this to this point on a x axis, this distance is x, and on z axis if you draw a perpendicular here, then this distance is z. So in this way any point on R3 will be represented. These things you already know about that. So now we'll define a function. So if you have a function, if you have a set x which is the subset of Rn, generally whenever we are talking about the functions of several variable, we will talk about what do you mean the set should be open set, or a set contains open set, because it's required. Now what do you mean by open set, and what are the properties of that? For that, kindly see the description, and also you can see my one of the video which I made for region on a complex numbers. You can go and see that. In that I have explained what you mean by open set. So here your x is an open set, or either it's contain an open set, then a function f from x to R. If you can say f of x1, x2 up to xn, it has some value. It's say some scalar value is there, which may be functions of x1, x2 up to xn, and this is the known as a scalar field also. It is also known as a scalar field. In the physics, might be you have heard about the scalar product. So it gives you a scalar output. So this vector, if you can consider this as a vector, then its output is a scalar thing. It is not a vector, it is a scalar. So that's why it's called the scalar field. This x, it's called the domain of the function that you know, and the set of all points f of x1, x2 up to xn, such that x1, x2 up to xn belongs to x, it's called the range. That also you know, the range and the domain of the function, which you probably know in your first year class. You have in details you have studied that, but here the difference is you studied about the functions of one variable. Here the function is of many variables, that means several variables. Now GF is defined as the graph of the function. The graph of the function, if I can restrict myself for functions of two variable, then the graph of the function is xyz belongs to R3, such that this z is equal to f of xy, where x and y belongs to x, which is a subset of R3. So in that way we can also draw a graph of the function. So whenever you have suppose you have a function which is defined on some set A to R, which is where A is a subset of R square, then you have f of xy equal to some operation, let's say x plus y. If we can denote it, this is by z. So I can say z is a function of xy, and this will represent actually a surface which is of the form x plus y, you can say minus z equal to 0. So if you can draw this is a surface, you know that this will represent the equation of the plane. Whenever it is the functions of two variables is there, then geometrically it will represent a surface. See, the graph of G, if f is a functions of two variable, then it is known as a surface. Now we'll talk about some examples of functions of several variables. The first example I have already talked in the beginning of this video, that says that if you have A to R, if you define a function from A to R, where A I have defined as AB, which is subset of which is from R square, where A is positive and B is positive, which define as f of AB is equal to A into B. So here A is a domain, and what is this gives? It gives you the area of rectangle with height is A, base is B. And why I have taken this A is positive and B is positive? Because in the area of the sides of the rectangles are always non-negative. So that's why with that we can have this is one of the function. In the similar manner I can define another function, let's say G from x to R, where if I define x as all AB belongs to R, where A and B are positive, if I consider both of them are positive, and define as same way G of AB as equal to 1 by 3 A into B. So what will be this represent G of AB? G of AB represent the volume of a cone. If I can say that A will be the base area and B is the height measured perpendicular from the base. For example, if you can have this is the cone, then whatever the area of this base, that is A, and whatever the height will have, that is B, and the volume of this cone will be 1 by 3 pi r square h is the area of the cone, and pi r square will be the area of this circle. which is a base circle is there, and the height is h. So that's why this will be a function. This g is a function of a volume of a cone if we consider as this as a variable. The another example I can say it is the cuboid. If I can take cuboid, then volume of this cuboid also is a function of 3 quantity. If this is a, this will be b, and the length will be c, then we can define a function h which is of ABC, and the area will be a into b into the. What is the domain of this function? The domain of the function is ABC such that a, b, c are positive. This will be the domain of the function. Now fourth example, if I have as a go into the economics or in that real life example, suppose you have a one bike and you want to rent that bike to some person, then what should be the price of that rent bike you gave? It will depends on or how many number of days you rent the bike, and another quantity is how much number of miles you ride to that. So that is the, if I can say, the number of days I am defining as a d, so that is the number of days you rent the bike, and if I can write m as the number of miles or kilometer you drive. So based on that your bike rent will be depends. So if you can say the rental cost of the bike will be a function, it is a function of this dm, and whatever the function you can have, that function, whatever, suppose you drive a number of days is the whatever, and number of miles you drive, so that will gives you this value. So this is also the example of functions of two variable. If I can have the fifth example, which already talked in my first video about the Muscabun. So if you want to have a cost of Muscabun, then if I define a b as the price of bun, and m I define as the price of musca means butter. So with these two things, the price of Muscabun is depends. Yeah, of course the price of bun is also divides into flour and all sort of things, how it is making of a bun, and that means the procedure of the things. But here we are talking about the price of Muscabun. If you want, if shopkeeper want to make it, then it has to be a functions of these two things. So z is equal to f of bm. That is also functions of two variable, you can say. So in that way the functions of many variables is depends on in real life situation is also. In the first lecture I talk about the temperature. So temperature is actually functions of not 2 or 3 variable. It's many variables are depends on the environment, natures are there, and you need to study about all sort of things, and then you can conclude that why the temperature is sort of things is there. We'll go to the next example. Suppose I am defining a function or a relation, the z is equal to square root of 1 minus x square minus y square. Now what is this? First of all the question is, what will be the domain of this function? So domain of this function is the square root is always positive. So that's why 1 minus x square minus y square is greater than or equal to 0. So you will have the x square plus y square is always less than 1. That will be the domain. So domain of this function will be all xy belongs to R square such that it will satisfy. That will be the domain of the function. If you can try to plot this is as a function, then what will happen? Suppose the value of x and y is 0. So if you have a 3-dimensional figure, now as I talked about, the z is equal to f of xy is represent the surface. So this will represent one of the surface. What is that surface? Let us try to see. So if you can have your xy is 0 here, then z is equal to 1 is there. If x and y is 0, you will have z is 1. So it is gives you 0, 0, 1 point. So this is x-axis, this will be your y-axis, this will be your z-axis. Then it will gives me 0, 0, 1 point, that is on here. This will be the 0, 0, 1 point. Now I may write this is as also if z is 1, that is 1 minus x square minus y square. If I take the square both sides, so and this 1 is cancelled out, so we will have x square plus y square is 0, so x is 0, y is 0. So that will represent a 1 point that we have here. Suppose z is 0. If z is 0, then you will have x square plus y square equal to 1. That will be gives you circle in xy plane. So in xy plane, if this is your xy plane, that will gives you a circle with center 0, 0 and radius is 1. And what will happen is this actually, if z is 1, it will gives me 1 point. If z is equal to 0, it will gives me this circle. If I have z is equal to 1 by 2, what will happen? If z is 1 by 2, you will have x square plus y square equal to, so here it is 1 by 2 equal to square root of 1 minus x square minus y square. If you do the square, this is 1 by 4, 1 minus x square y square, and x square plus y square, so it will gives you 1 minus 1 by 4, so that will gives you 3 by 4. So 3 by 4, so it will also gives you one of the circle with the radius 3 by 4. So it will be a smaller circle with center, sorry, at the place 0, z is equal to 1 by 2 and so on. So if you can draw the different value, if you interchange the different values of in between 0 and 1, what is this figure is look like? This figure is, see, if I plot this point 0, 0, 1 is here, if I plot 0, 0, 1, and if I plot this circle here, and on top of that there is another circle is there, which is with the smaller radius, with the radius of 3 by 4 and so on. If you take another value, let's say 1 by 4, then you will have a very small circle than this. So you will have circle here, that circle will be here, and so the graph of this or surface will be, it is look like a paraboloid. And I have drawn the graph of this function in one of the software. In this you can say that this is the point that we have said, it is the point 0, 0, 1, and this is the circle that we have. So in that manner we can plot such a graph of the function. Let us take one more example. Let us consider the example z is equal to square root of 1 minus x, x minus 2 plus square root of 3 minus y, y minus 4. So if I consider this is as a function, then what will be the things, or what will be the domain of the function? If you want to first calculate the domain of this function, then this quantity has to be positive as well as this quantity is positive. So that means you required 1 minus x into x minus 2 is non-negative. That means it has to be a non-negative quantity. If you want, this is the non-negative quantity, that means your x is between 1, because this has to be non-negative, this has to be positive, or both of them are negative. That is the way you can say that. So your x is between 1 and 2. Why? Because 1 minus x is positive and x minus 2 is also positive. 1 minus x is positive will gives you 1 is greater than x, and x minus 2 is also positive will gives you x is less than or equal to 2. So that will gives you x is between 1 and 2. Similarly, you required 3 minus y, and y minus 4 is also positive. The this condition will gives you the y is between 3 and 4. So that means what will be the domain of the function? You will have a domain of the function will be set of all x, y such that x is between 1 and 2 and y is between 3 and 4. That means it will be a rectangle rectangle area that we have. So that is the area. What is this area in xy plane? It is x is between 1 and 2, so this will be the x is equal to 1, and this will be the x is equal to 2, and y is 3. Suppose say this is y is 3 and y is 4. So what is the area you will have? This is the rectangle, whatever the rectangle is, this is the domain of this function. So it is bounded by 4 lines, x is equal to 1, x is equal to 2, y equal to 3 and y equal to 4. And what will be the graph of this function? So the graph of the function is look like this. Now we'll take the one example, the relation z is equal to e power minus x square minus y square. Now this will be also a functions of two variable is there. What will be the domain of this function? The domain of the function is r square. Why? Because the e power exponential function is defined for any value in r in functions of one variable. Here so it will take any value of minus x square minus y square it will take. So this is the domain of this function is r square. And what will be the range of this function? The range of the function is x greater than 1, more than 1. So all the x which are bigger than 1, this will be the range of this. Now the next I am giving you as an exercise give the domain of the following functions. Also draw them in the online 3D plot. See, if you want to draw this is as a 3D plot, you can use some of the software is available. For example, MATLAB is there, Mathematica is there, or you can use the R is there. So there are many software which plot such functions. So you can use them, and also there are online 3D plots are also available. You can make a use of that one, and you can try to plot such functions and give the domain and range of the function. The first function is z is equal to 16 x square minus y square under root. The second example I can say z is equal to x plus y upon x minus y. The third example I can give you is 1 upon log x plus log y. So you can try these examples, and also I am giving you as in one of the exercise, find out the real life examples of functions of many variables. That means as I give you examples in this talk, you can try to find out yourself what are the examples of functions of many variables are there in your real life. So that's it for today's lecture. Thank you very much. If you have liked this video, please press the like button. If you have not subscribed yet, please subscribe the Shanti-Peace for Mathematics. And if you have any questions, you have any comments, you have any suggestions, kindly drop down on the comment box. So thank you very much. Bye bye. Sayonara.